Let's just dive right into this, guys, because if there is one harsh reality every single engineering team is waking up to in 2026, it's this. Picking the wrong AI agent framework doesn't just slow you down a little bit. It literally leads to debugging nightmares that completely derail production. Welcome to The Explainer. I'm host 1, and I'm joined by our technical analyst, host 2, and our founder and CEO, host 3. We are the team at AISHO Consulting.
Great to be here. And yeah, you hit the nail on the head. The stakes have absolutely never been higher for CTOs making these calls.
Exactly. Today, we're breaking down the architectural realities, the developer experience, and those really subtle, hidden edge case pitfalls you absolutely need to avoid when making your framework decision. So, here is our roadmap for today's explainer. First, we'll map out the agent framework landscape. Second, we'll compare graph versus model-driven execution. Third, we'll look at type safety and TypeScript tools. Fourth, we'll get into enterprise deployment and observability. And finally, we're doing some head-to-head framework decisions. Before we even look at the tech, I want to pose a really high-stakes business question directly to everyone watching. Is your current AI framework built for prototypes, or is it actually built for production? Because, look, patching together some prompt engineering scripts might look like absolute magic in a demo environment, but in production, it is a massive liability. Picking the wrong stack necessitates emergency upskilling for your team, and it's going to eat up your entire integration budget. You need a foundation built for scale. Right, which perfectly brings us to section 1, the agent framework landscape. Let's see what's actually out there. So the technology has rapidly matured from simple prompt engineering into this massive ecosystem of specialized multi-agent architectures. If you look at the LangFuse data we've got on screen here, we've categorized over a dozen top tools strictly by their primary language and their core engineering paradigm. You've got your graph-based workflows like LangGraph and Microsoft Agent Framework that give you super explicit control. Then you've got opinionated harnesses like deep agents. We also have lightweight, model-driven primitives. Think the OpenAI Agents SDK or Strands. And of course, highly specialized tools like Pydantic AI for type-safe Python, Mastra for TypeScript, and Crew AI for role-based teams. Digesting this matrix is really step 1 to narrowing down your options. Moving right along to section 2, graph versus model-driven execution. This is where the rubber meets the road. Yeah, this brings us to the core architectural debate engineering teams face today. It's really about choosing how much control you manually hold on to versus how much you hand over to the AI. A graph-based workflow actually treats AI tasks as nodes in a directed graph. As you can see, this provides explicit execution paths and durable execution. Tools like LangGraph or Google's Agent Development Kit operate this way. So you contrast the strict, durable control of graph-based enterprise workflows against the rapid development speed of simpler, model-driven loops, where you basically just define a model, give it some tools, and let the loop run autonomously. And I'll jump in here because the crucial point is the business trade-off shown on screen. Model-driven, simple loops, they are fantastic for rapid prototyping and fast iteration. But enterprise compliance, that requires predictable, auditable execution. You need branching logic and durable, long-running processes that don't just crash and burn if a single API fails. Now, shifting your engineering team from a traditional software mindset to this graph-based agent mindset is a heavy lift. It's a completely different way of thinking, but it is a necessary evolution for production-grade reliability, which is exactly why our upcoming AI LMS platform at AISHO is specifically designed to teach these enterprise paradigms. Spot on. Okay, section 3, type safety and TypeScript tools. Let's talk about the developer experience. Let's see how all this builds into the actual dev experience. Specifically, type safety is fundamentally preventing asynchronous bugs and context drifting before the code even runs. To prevent those bugs, a huge standout right now is Mastra. It's a TypeScript-first framework supporting over 40 different model providers. This incredible flexibility unifies model routing and effectively prevents vendor lock-in. That is a massive win for native JS and TS teams who want workflows, memory, and evaluations bundled up in one integrated package. And if you're over in the Python ecosystem, Pydantic AI is totally changing the game. You define your agent inputs and outputs as strict Python types, and the framework handles all the validation under the hood. It catches structural errors at write time instead of runtime. It acts very much like Fast API, but for agent development.
Exactly. And from a business perspective, adopting these strict typing contracts drastically reduces your integration costs. Developers spend way less time chasing down completely hallucinated JSON structures and way more time building core product value. It's a no-brainer.
Let's shift gears to section 4, enterprise deployment and observability.
because getting it working on localhost is one thing, but deploying it is another beast.
Right. Let's pivot the discussion to the reality of deploying these agents into the wild. We're using Google's Agent Development Kit, or ADK, as the ultimate case study for what enterprise scale actually requires. Looking at the features on screen, this is what true production-grade architecture looks like. We aren't just talking about a script anymore. We're talking about deploying to world-class infrastructure that includes a built-in RAG engine, durable memory banks, a central agent registry for governance, code mender for fixing security vulnerabilities, and an agent gateway to manage traffic and authorization. I have to say, I absolutely love this quote we pulled from the Google ADK documentation. We treat context like source code, where every token earns its place. This brilliantly illustrates a critical financial point that a lot of leaders miss. Simply overflowing a context window with garbage data costs you real money in token usage, and it completely destroys the reliability of the agent. Managing context drift natively by filtering events, lazy loading artifacts, and summarizing old turns, that saves massive operational costs at enterprise scale. That is such a good point. All right, finally, Section 5, head-to-head framework decisions. It is time to pick a winner for your stack. Utilizing recent LangFuse insights, let's look at the most heavily debated head-to-head framework decisions CTOs are currently struggling with. First up, the highly requested Python matchup, Pydantic AI versus LangGraph. The recommendation here is super clear. If your priority is strict validation, type-safe logic, and you want minimal ceremony for single agents, go with Pydantic AI. But if you need explicit orchestration of long-running workflows, parallel branching, and human-in-the-loop interrupts across multiple agents, LangGraph is your undisputed choice. Next, we weigh the model-driven approach of Strands agents against LangGraph. Strands gives you really fast iteration and runs the agent loop for you. What makes it a top contender, though, is its deep AWS and Bedrock integration. AWS-heavy teams benefit immensely from Strands built-in OpenTelemetry tracing. LangGraph, on the other hand, gives you deterministic control and a massive framework-agnostic ecosystem, so it really depends on your cloud footprint. And finally, let's tackle the enterprise infrastructure decision, Microsoft Agent Framework versus LangGraph. Look, if you are an existing .NET shop and you're heavily invested in Azure, the Microsoft Agent Framework is essentially the mandatory choice today. It's the official successor to AutoGen and Semantic Kernel. However, if you are working in Python or JavaScript and you rely on wide third-party open-source integrations, LangGraph continues to dominate that space. To summarize the overarching executive lesson here, and you can see it right on screen, match your AI tool to your team's existing ecosystem and language expertise. Do not force your .NET team to learn a niche Python framework just for a prototype. It's a huge mistake. Seamlessly upskilling your team within their native ecosystem is the absolute key to successful production scaling, which is exactly how AISHO helps organizations navigate these transitions. Well said. And that brings us to the end of our explainer. I want to leave you with a final thought to mull over. Are you ready to audit your stack? Because as AI agents become more autonomous, the question isn't just which framework you choose today, but whether the foundation you lay right now can support your AI workforce of tomorrow. Drop a comment below with your company's current tech stack, and be sure to visit aishoconsulting.com to book a strategic audit or get early access to our upcoming enterprise AI LMS platform. Thanks for tuning in, and we'll catch you in the next explainer.